Still taking its time, huh? Did you actually hit that upload button? Yeah, it's waiting.
All right, here we are in TLS meeting. We're still looking for a note taker. We'd like somebody to take notes. You don't have to capture every discussion, just the action items. Rich Sauls will take notes for us. Thank you. All right.
If you do them in the Etherpad, Rich, if he does them in the Etherpad, then other people can follow along. All righty. Here's the note well. It's Monday. You may not have seen this yet. Basically, you're going to get recorded. Behave professionally. If you got IPR, you need to discuss it or disclose it. All good and well. Request. We got a minute taker. Thank you. We got a JavaScribe. The blue sheets are being distributed now. Make sure to sign those. Put your name and your affiliation on there. When you get to the microphone, please state your name at the mic for the note takers. Let's keep it professional at the mic. And I'm adding a new one to keep it succinct at the mic. I don't know. Sometimes people do monologues. We don't always need those. All right, so the next thing is the agenda. I think there won't be any agenda bashing this time, I hope. Basically, we're doing the administrivia now. Then we'll look at the GTLS 1.3 draft. Then spend a couple of minutes talking about the deprecating TLS 1.0 and 1.1. Then a bunch of time about encrypted SNI and TLS. And then we're going to kick over to proposed charter text that we suggested. Then we have some non-working group drafts. That's what that line is. Trying to figure out if they want to be adopted or not. One with PSK plus certificates, additional certificate types to support vehicle-to-vehicle communications. And then we have these two ideas about PSK importers and universals and trying to figure out what, if anything, we want to do there. And then we have another one called ticket requests. The agenda for Wednesday, our next session, is all about DNSSEC chain extension and what if we can do anything to move it along. There are some preliminary slides already uploaded for those as well. Document status. Since the last time we met, we've actually published 5 RFCs. ECC Cipher Suites for TLS 1.2 and earlier to standard track. We did our RFC 8422 elliptic curve Cipher Suites for TLS 1.2 and earlier. We did some elliptic curve Diffie-Hellman PSK stuff with GCM and CCM for DTLS version 1.2. The draft everyone we've been waiting for, TLS 1.3, and some, yay. Some IANA registry update drafts. A record size limit extension for TLS, which was probably has the record for being the quickest one ever through the working group. We have in the RC editor queue now, we currently have an example handshake traces for TLS 1.3. I guess that's going to get spun as soon as it gets to the auth 48 stage. It's kind of a pain apparently to pull the crank, so we only want to do it once more. Since the last working group meeting, we cycled the ADANE record and DNSSEC authentication chain extension for TLS back to the working group. We also adopted 2 new drafts, which are this deprecating TLS 1.0 and 1.1 and encrypted SNI for TLS. We did a working group last call for the issues and requirements for SNI encryption in TLS that we're thinking we can probably pretty easily resolve those issues on list and then get it out of the working group. Soon to be in working group last call, we have 3. The exported authenticators draft for TLS, the DTLS connection ID, and Greece. Basically, I need to get together with the authors for Greece to get them to include a couple sentences, but then I think it's pretty much ready to go. And in progress, we have DTLS 1.3, a certificate compression draft, which seems to be going pretty well. They're experimenting with it now with the early code point assignment we had, and the delegated credentials, which we suspect that we will hear a lot more about next time in Prague or wherever we're going to go. Okay, what's next? So the TLS designated experts stuff got set up as a result of RFC 8447. So we wanted to let you know who they were in case you missed it in the email that got fired off. They're Rich Saltz, Nick Sullivan, and Yov Nir. If you have a request, you can fire it off to that mail list. The archives are now public, so you can see the requests. We don't want this to become an alternative place to discuss TLS things. This is, if you have a request, it goes over there. They round robin figure out how they're going to do it, and they get back to you. If they don't get back to you in time, there's ways to fix that. So far, we've had these values registered. Only one was recommended as a yes because it came out of the token bind working group. The other ones were all kind of individuals stuff. So the first four, I think, were, one was for Peter Gutman's long-term stable TLS draft thing. There were then 3 for Dan Harkin's Dragonfly draft, 3 Brainpool curves for supported groups, and then a bunch of exported label values for 1 M2M. And it's 1.3. Yep. So, and that's it. We're going to put this on every time just to make sure that people are kind of aware of what happens and what gets done, so no one's really caught off guard, so that maybe you don't have to go and check the pool list. But that's it. Now we're going to move on to TTLS 1.3. Okay, I hit that, and I hit this, and you get that.
Did that actually work?
Yeah.
I thought it probably was, but okay. No.
All right. So this is actually pretty straightforward. I'm going to start with summary of the changes we made, and then have a few not really open, but quasi-open issues, and then say I'm done. So we screwed around with the header format repeatedly. And in the last version of this, we had a header format with like a bunch of empty blank space that we marked as reserved. And Martin Thompson pointed out that we could shift things around and wouldn't have, and make the sequence number longer, but also have less blank space. So we have the following structure now. The first, as it's been for quite some time, the first 3 bits have to be 0, 0, and 1. That like masks off a specific region of the code point space. There's a C bit, which means the CID is present or absent. 1 means present. There's a L bit, which says the length is present or absent. And then there's a sequence number length bit, which says how long the sequence number is, and then 2 bits for the epoch. And I'd forgotten to mention this, but when I looked at this, I think these are probably in the wrong order, so I'm actually going to probably shuffle them around. But other than this was your order, but so probably I'll probably move around a bit. But other than that, no one cares where these bits go. So the basic idea is there's like, I don't know, there's 8 separate forms depending on which bits are set. But they're all fairly straightforward. Basically, things are present or absent. So this gives us a unified header with a nice range of with a length or not, and a nice range of sequence numbers that should be big enough for anybody. No, I don't think anybody thinks more than 16 bits of sequence numbers needed. So this was an initial draft. Nobody complained. This is what we discussed last time. So this is just a briefing. If somebody objects, speak up. But I'm just going to keep going otherwise. All right. Oh, and here are some examples that show like the smallest possible thing on the right and the biggest possible thing on the left. Okay. The second big change is we added record number encryption or record sequence number encryption. This is basically the same technique Quick uses that we just stole. So the basic idea is that you establish a shared key as part of the key schedule. It's not the record layer key. It's a sequence number key. And that key is used to generate a mask with the, it's effectively a PRF using using some of the ciphertext as the input to the PRF. The specific function actually depends on the algorithm you negotiated, but for AES, basically you compute AES ECB of the ciphertext. And then you take that mask, you XOR the sequence number. Quick has a somewhat different description of this, but this is a natural algorithm. that Martin and I disagree about what the most succinct way to describe it is. Oh, who was it? Oh, other haters?
So I tried several ways of describing this, and no one was happy. And so I went with the last one that I ended up on and landed that anyway. It's different to what you have here. I started with what you have.
Yeah. One thing worth noting is DTLS is not quite as aggressive as Quick about encrypting all the control bits.
Right. So in Quick, we're going to be encrypting the epoch.
Right.
Because in Quick, we're going to make the sequence number protection key fixed over the lifetime of the connection, whereas here.
Yeah. So, I mean, if people think we should encrypt more, we certainly can. One thing that was extremely annoying in Quick is not knowing how long the header was. So I'm like not super excited about encrypting the control bits here.
Right. And you certainly can't encrypt things like the connection ID bit because those are typically used by something that's not privy to the keys.
Right. So I think I'm tempted to leave it the way it is, but if somebody thinks more. And DTLS is generally not as aggressive at Quick as encrypting everything anyway. Okay. Third major announcement. TLS 1.3 has this compatibility mode that would let you get through screwed up middle boxes. There's like no point in having that for DTLS 1.3 as far as anybody can tell. So the spec kind of said you shouldn't use it, and the spec really says don't use it. So that's just like concretizing that. Okay, so now to the actual technical matters, such as they are. TLS 1.3 has this handshake message called EOED, end of early data, at the cutover between the early data fields and the client's second handshake flight. So in TLS, what this tells you is now is the time when I'm not sending any more early data, and the next thing you're going to see is going to be handshake. And so in TLS, you need this to avoid a child encryption because the state machine is like a lockstep state machine. It also has the effect that it prevents truncation attacks because you're changing keys and you're changing sequence numbers. If you don't know when early data ends, then the attacker can just pull off a bunch of early data and have it go away. And then you just think the early data, you basically got a slice cut out of the data between the early data and the one round trip data. So neither of these things applies to DTLS. DTLS is like a perfectly good like field that says like which keys things are encrypted in, so you know what you're doing. Because DTLS is lost anyway, the truncation attacks don't apply. And it would just say, well, they apply in the sense that you can always mount them and that the EOE does not prevent them. However, if you do have EOED in the protocol, this is a potential cause of blocking because you can lose the EOED and then like you could be processing data, but you can't now. So like this is irritating. And when Quick did the TLS 1.3 binding, we just removed EOED from the whole thing. And this like gave everybody like a little bit of angst, but like nobody could figure out a real problem with it. We thought about it pretty hard. My proposal here is to do the same thing here, which is basically just strike out EOED. This is done in PR number 62, which has a parentheses after it, even though there's not one here. One thing to note is this affects the handshake transcript. So because EOED is part of the handshake transcript, this affects the transcript. But that really shouldn't be a problem anyway. But famous last words, I know. We're going to attempt to convince, Karthik or someone to analyze this for us, but it is probably pretty straightforward. This was not controversial and Quick. It might be controversial here. I'm going to wait a second or two. Okay. I'm going to merge this PR. Yes, the second change I made is the connection ID mechanisms in DTLS. At the present version of the specification have essentially one CID at a time. So when the receiver issues you CIDs, he can send you one, and when the sender asks for a CID, he can ask for one. And this is technically workable, but it has a few annoying properties. In particular, because when you send a connection ID, one of the things you say is, should you wash out every other connection ID you already had? And so if I want to basically send you 8 new, say the way I got things structured is I've got a bunch of receiver state whose job it is to remember all the connection IDs, and I want to blow away that state and issue you new CIDs, right? So what I do right now is I have to say, here is one new connection ID, forget everything else. Also, here are eight new ones, one at a time, right? And so those get reordered, then it's like a pain in the ass to process. If you basically just take each of those fields that's like 1 and make it n, then this problem goes away, because then you can basically say, here are 8 new ones, forget all the old ones. So there's a conversation Eric Kinnear and I had, and this is quite a substantial simplification. So the changes I made are, the new connection ID has an arbitrary number of CIDs. Other than that, semantics are the same. The request connection ID is a count that says how many more you want. And the other thing I did was, you can only have one of these, you can only have one of each type in a flight from you at a time, so that then you don't have to worry about reordering if it's to each other. So that makes things a lot easier. There's, there probably are some edge cases, like where you can be like connection ID starved. Even in Quick, we didn't really, we're sort of like, someone has to go write a Tamron model to prove to ourselves you can't starve yourself, but these seem pretty edgy, and most of the migration, which you don't expect to do anything. So this is my plan here. I have a PR for it. So not seeing anybody standing up, I plan to merge this as well. So these are the only remaining issues. My plan is to merge it. Not seeing anybody complaining about other things. My plan is to merge these issues, issue a new draft, and after working group last call.
So will that include a pause to get Karthik or Cass or somebody to give a thumbs up on the removal of the?
I think we should ask them for that, but I think we shouldn't wait for last call.
Okay.
And all the other thing is I'd like to see a fielded implementation, which we plan to do very soon. So I think if you prefer, you were the chairs, but I no longer plan to work on this document. I plan to start deploying it. So if you want to wait, if you want to do working group last call and then pause, or pause in your last call, I don't care.
I would prefer to do the working group last call now and then pause.
So would I.
Gives them more time.
Yep.
So basically, when you spin it, the next version, when we see it, we will take it and start the process.
Yeah. So Martin Thompson, it's going to take us a little while to implement the latest set of changes and get them deployed and all that business, but we're committed to doing that. So in that time, we hope to be able to convince someone to give us a bit of analysis time.
Yeah. Thank you.
What are we doing next? What are we doing next? Next, we're doing deprecating. Deprecating. There we go.
Okay, so it's only about 3 slides. So this is a draft. I guess we talked about it last time, got adopted. Kathleen's not here till tomorrow, but she will be here then if you want to talk to her about it. So then there's only a few issues with this really in terms of the text. So basically, I think a tricky issue is going to be does this update or obsolete, what the hell? That's probably making a long list. There's one issue is that it's changing something in the BCP, so does it become part of that BCP? I'm guessing this is all kind of boring, so we can just kind of work it out with the chairs, and the ADs and the ISG will whine about it later. So
Yes, absolutely. Most people will not care about any of this.
right, that's okay. There's some text in there about kind of current measurements, and there's a question whether we leave that in or just delete it before it becomes an RFC. If anybody has an opinion, just state it. I don't really care too much.
Yeah, so Martin Thompson, I think there's a lot of argumentation in the draft motivating its existence. And some of that is quite solid in the sense that, outdated algorithms and all those sorts of other things. But the measurement related stuff, I don't think really has much place in the sort of permanent record that we're looking to create here. So yeah. I'd be happy with it coming out. It's pretty convincing, but I think it's good without it. And also, fewer words are better.
Yeah, Eric score the less the better.
Sure. Okay.
I'm just going to stand here because I have an opinion about this next thing.
Okay. So if nobody contradicts that, that's what we'll do, and then so on. So then there's the third issue is this section 8, which says don't use SHA-1 as a signature hash. So again, this could be something that should be. You could argue this should be done separately. So argue.
Yeah, I think it should be separate. I don't object to the thing, but things should do what it says in the tin. And what it says in the tin is deprecating 10111.
Yeah, Hubert suggested it. Gave us a PR, so he said we leave it in and then asked the working group if it was adopted. So unless there's some other reason to do this here, we take it out. I don't know if there's some other place to do it, but you guys can think about that. Yeah. So those are the only kind of doc texty kind of issues really, but then I guess the bigger issue is when to progress this. And again, our esteemed chairs will tell us the answer, or what they think the answer is. So basically, I guess the real kind of question seems to be, is the mail infrastructure sufficiently different to the web to want to do this at different times or not? And I think myself and Kathleen think going ahead is probably fine, but the numbers are a bit different. So if people have opinions on that, I guess now is a good time, or do you want to wait until you do a working group last call or something? Sean's vaguely shaking his head, I think.
So Martin Thompson, I'd be happy as seeing this published relatively soon. You might have noticed that we've, at least some of us have taken steps in this direction already in terms of deployment. So it would be good for us to have something more concrete. If that would be published sometime before the start of next year, that would be also good. Maybe the year after even. I mean, I'm not in a huge rush, but I don't see any reason to hold this. It's time to move on.
Yep.
Ben Kaduk, no hats. Just it seems like the question of whether or not something is bad is completely orthogonal from whether or not people are currently using it.
Fair point.
Yes.
Yeah, Eric Esprola. Yeah, I mean, I think that I think that part of the motivation for moving the measurement is that the IETF position is this stuff is no longer at current standards, and you should stop using it, and you stop using it at whatever pace is practical for you to stop using it. And maybe you have a situation where it's impractical and then it would take longer, but with our opinion, you should stop.
Okay, so I think that's given, the input that's there was fairly clear. We'll make those changes, submit a draft, and then you guys can decide to last call it.
Yeah. Okay. No time like the present. Yep. Clicker. Who's next? Encrypted SNI. Let me just do this because I uploaded a new version. Almost like I know what I'm doing. Is this thing here work? Yep.
Use the screen.
No.
Screen does not work. Okay. So we're going to be chatting a little bit here about encrypted SNI. This was the draft that was proposed and adopted. Oh, here we go. Yep. And we've had version 0, version 1, version 2 published. These early versions have been deployed for testing situations with Cloudflare. So all of Cloudflare's customers have ESNI support, as well as Firefox Nightly has implemented a compatible version about this. This was not without its pitfalls, as I guess we'll discuss later. And there was also a lot of discussion on the list. I had an overview slide, but I was too late to get it to the chairs. But the general overview of encrypted SNI, for those who have not been following, is that there is a key published in DNS called ESNI. It was in the original draft, in the current draft, a text record with a prefix, and this contains a structure with a public key. And when a client is meant to connect to that server that has ESNI enabled, rather than sending an SNI extension, it sends a encrypted SNI extension, and the content of that extension contains a reference to the key that was used, and the key in DNS is a Diffie-Hellman key. This is combined with a client-side Diffie-Hellman key to create an encryption key for the SNI value, and the public key for this encryption is sent along with the client hello. So this has some features in it to prevent it from being replayed, and the goal is for SNI to no longer be clear text on the wire. And so for those following along. There were some changes from the original proposal. In the original proposal, the Diffie-Hellman key share that was used to encrypt the SNI value was also the one used in the TLS handshake. This has been separated. There's now a separate key for ESNI. And this was meant to protect from essentially DNS being able to dictate with which Diffie-Hellman share is going to be used for the connection. There was also a few additional features added for replay protection. This is a nonce, as well as the AEAD for the key share, the additional data in the AEAD for the encrypted SNI value covers the key share in the client hello, and this prevents replay. There was a version added as well for future compatibility. Not many changes. So there are some pending changes being discussed. The main one was the use of a specific RR type for ESNI rather than a text record. This does simplify some situations. You no longer have to have a underscore ESNI label to obtain the ESNI key. This simplifies CNAME setups. It also makes it easier to deploy new types if managed without users, and there's a couple opinions about it being more correct use of DNS. Yeah, question.
Edward Dean, Symantec. So I have a statement, a question, and a follow-up. So several middle boxes that do TLS inspection depend on the SNI in order to make a policy decision about whether or not to do a decrypt on that session. And with this proposal, it's going to break the middle box's ability to do that. At Montreal, we had talked about, okay, if a middle box wants to participate, it can potentially, if it has access to the DNS, it can censor out the ESNI TXT record, basically disabling ESNI totally for the session. I'd like to make a different proposal for that, one where we can still have ESNI working, but have it work with both the middle box and the ability to communicate with the fronting server. And the proposal is to basically allow, if a middle box can inject something into the DNS record, have it inject a vector of ESNI keys where you can have an ENSI key for the fronting server, as well as similar keys for the middle box or possibly middle boxes that may be in the path, and have a requirement be on the client that if it detects that there's multiple, like a vector of ESNI keys, it actually encrypts the SNI in multiple headers, in multiple extensions, such that if a middle box gets the client hello with an encrypted value inside of it, it can actually decrypt its portion of that to determine what the SNI is, make a policy decision. And if it chooses not to do the SSL inspection or the TLS inspection, it can just pass through the remainder of the stream untouched, and there's nothing that would break. And then if it does, then it can proceed to do the termination of the TLS and do its inspection at that point. This has a couple of benefits. It makes it a bit more transparent that there's a middle box there. So the client now knows that there's a potential middle box that wants to participate in the TLS session. The fronting server may also get some visibility into this as well, because the client hello would actually indicate that I've encrypted my SNI for you, but I've also encrypted it for another party in this session. So we don't have to disable the encryption of SNI when there's a sanctioned middle box in the way that wants to potentially do TLS inspection. So that's my proposal.
Can I ask a clarifying question? Yep. Ted Hardy, clarifying question. I didn't hear anything in what you just said that had anything to do with switching from the TXT to RR type. What did I miss?
It's not related to that at all. This
okay,
is a brand new proposal.
You're just throwing it in at this point because it was a handy one.
Yeah.
As a response, the ability to use multiple ESNI keys is something that potentially has other applications. It hasn't been discussed on the list, though.
No, it hasn't. I apologize.
Lorenzo Colidi, what are the implications for anyone who wanted to sign that DNS record, though? Right? So you're basically moving the problem where you want to do intercept at the SNI layer to now you have to like you're basically like running away from the security train that's going to hit you. And it's like, well, okay, the first line of defense is encrypted SNI. Okay, well, we'll monkey around with DNS because DNSSEC isn't rolled out yet. But so basically, we're just moving the problem down to DNS. So that proposal would have essentially it would mandate inability to do DNSSEC, which kind of means you basically, because DNSSEC is a decision of the sort of person owning the domain, you basically disable it for the clients for every host name. So that's kind of a very different impact than I guess you just blocking this, right?
Well, I mean, I'm not enthusiastic to the proposal, but given that the premise of this proposal is that that these guys are installing a trust anchor on your client, the fact that they're going to intermediate DNSSEC does not seem like the most serious part of the problem. I guess I don't think this is the right place to do this. It might be the case that one would want to have some mechanism for clients. It might or might not be the case. There are mechanism for clients to exfiltrate to the middle box what the SNI was, but I think trying to take a mechanism which is an end-to-end mechanism and layering and a middle mechanism at the same time is like not like the right place to manage that. And again, I'm not taking a position that is a good idea in the first place.
Yeah, my only response to that would be TLS is designed to be a point-to-point protocol, but in practice and use in enterprise, it's not. There are multiple parties in the system, and we have to work around the way TLS was designed and effectively hide the fact that we're doing inspection, whereas here we have the opportunity to do it quote unquote the right way and in a more transparent way so that we're actually recognizing the fact that some enterprises want to have the ability to participate in this. And if we design the protocol to allow that, it's a step, in my opinion, it's a step in the right direction rather than trying to hack around the protocols to accomplish something that there's a real world need for.
Ted Hardy, I tend to support Ecker's point that this is probably not the right place to do this, partly for the reasons that Lorenzo already put forward, but also because it now creates a dependency that you're kind of getting your DNS from the right server, because the chances that the public server that's able to look at this RR type from beyond your enterprise has this available is very small, which means that if you have a DOE server or some configured server that's not using the local enterprise server, now the enterprise is both going to have to block access to that in order to force you on to some locally configured server that has this additional RR type record in order to do that, as well as block any DNSSEC validation you might have done as a client in order to trust the DNSSEC validation that's being done on the server. So I think that the analogy Lorenzo said was you've moved the stop, you've moved one stop down the set of train stations, but the train is still coming for you. The side effects of this seem bad enough that starting with this design in order to accomplish the exfiltration is probably not the right way to do it.
Rich Salzakamai, one advantage this gets you is if you have things that are out of sync, such that, origin or gateway servers that aren't tightly synced to DNS and TTL or they've lagged behind, then you can put new and old keys in the ESNI record, and then things won't break.
Yeah, I think it's worth differentiating between the motivation and the definition of what this proposal is.
Jonathan Hoyland, I might have missed something. Was there some obvious mechanism that that the ESNI, the multiply encrypted, all point to the same place? So you just send one thing that won't be expected to the middle box and connect wherever you wanted anyway?
Regarding having a separate key for ESNI for the middle box to show. Well, my point would be that server selection is it's a client and server's role. So server sends so clients first signals what the server it wants to send to connect to, and then the server in response tells you to which server it's actually being connected by using the certificate message. So I'd argue that just looking for ESNI is a technically, it's not an ideal solution if you want to look to determine to which server you are actually connecting to. So I think what you should shoot for is to get access to the certificate message. That actually tells you to which server the client has connected to.
Lorenzo Colletti again. Sorry for maybe sort of rat-holing this discussion, but I wanted to ask, forget the name, the gentleman from Symantec, was there any thought to basically like allowing exfiltration only essentially on device as opposed to on network? Because a device that's an enterprise-owned device may have different security zones where, if you do this, the enterprise admin has, all the keys to the kingdom. But if you do that, you're running this other app, this other work profile, whatever, then it doesn't. And so I think if the exfiltration was done on the device, then maybe, assuming that there's a root cert on the device or something, then that would sort of allow for differential privacy expectations in these contexts. And I wonder if there's something which makes it hard, because the proposal was basically doing this in the network, in the middle box. But I think all of these devices these days, they have enterprise management algorithms that, and modes that we could use. So I wonder if there's something that's inherently hard about doing it that way as opposed to this way. Not this way, the way that was proposed. And I don't see anyone coming. Oh, there you are.
No, I think the assumption was in writing this draft that the enterprise mode of the client could potentially kick in, and ESNI would be disabled.
But you don't even want that, right? Because you want to spy on your users, but you don't want the internet to spy on your users, right? So as an enterprise admin, you want to basically see everything that they're doing, presumably assuming the law allows you to do that, but you don't want the internet to see what they're doing, right? So yeah,
that's correct.
So I wonder if a way out of this conundrum is to say, look, this is how it's going to work, and if you have the ability to push a root cert on the device, or if you have the ability to run code on the device, then this is how you do it. And then all the implementations could do this, or not if they didn't want to sell to enterprise markets, and then we'd have a solution, right?
So is the proposal potentially installing an additional ESNI key locally and then encrypting your SNI to both the one discovered through the network as well as the one that was installed locally?
I don't pretend to understand the complications, I'm afraid.
Okay.
Just trying to understand the user visible behavior, which is why I just asked, could it be done in another way?
It could.
Yeah, I apologize for hijacking most of your time. Just to respond to the one question, why can't you just always do it in the endpoint? For most enterprises, they want to run a situation where you don't trust the endpoint, you don't trust the network. So you want to have a layered security model where you can do exfiltration in multiple places so that you've got yourself covered. So that's why the desire to do it in the network exists.
Stephen Farrell, could we talk about encrypted SNI instead?
Yep, let's move forward. So with encrypted SNI, there are two major operational issues that were raised in both the deployment and in questions about clients deciding not to deploy the draft as currently built. The first is the potential for a hard failure if the DNS and the server get out of sync. And then the other one that was raised on the list was the multi-CDN case. So I'm not going to propose solutions for these. For the first one, I'll sort of hint at some potential ideas for getting around it, but I want to raise, I guess, the problem statements around these potential operational issues. First, the hard failure. So your risk is your DNS caches your ESNI longer than your server keeps it around, and this is a bigger risk if you're doing fast rotations of keys and you want to have forward secrecy around this, so you want to delete the keys pretty quickly. Also, if the organization if there's two different organizations that manage DNS and HTTPS and somehow they get out of sync, these things happen. It's not common, but it is a risk because ESNI is currently defined. The way that clients would deploy it is to not have a fallback. So if the key has a mismatch, this would be a vector for an attacker to force the client to reveal the SNI that it was going to. So the impact of this is unavailability. You, as a client, you'd not be able to see the site. So there's a possible idea for solution. which is to distribute the ESNI key through TLS, through the connection. One idea around this is typically if you connect to a site, there are servers that are able to handle requests that do not have SNI and therefore have a default certificate installed. You could potentially imagine a scenario where the server has a default certificate for no SNI and then another default certificate for an ESNI that can't be decrypted. You could indicate in the ESNI record that if you see the default certificate, this is a trusted channel for updating ESNI. So you would make a request. The server does not know how to decrypt the ESNI, the encrypted SNI extension. Instead, it replies back with an ESNI key, and this handshake is signed by a certificate that covers the, say, distinguished hostname for that ESNI key. And then you would terminate the connection and you'd resume with another TLS connection using the new ESNI key. So this is a case that should be rare because misconfiguration in this manner should be rare, but there are definitely issues with caching in DNS versus transitioning from one key to another. And we ran into situations that kind of mirror this in our initial deployment.
Clarification question. Let's say that you wanted to implement this with a resolver library, with an HTTP library, or with a sort of HTTPS, quick, whatever, transport layer library. You would need a sort of richer communication mechanism between those two than just here's an SNI record and here's the key, right? You'd have to also return the host name as well. But is that all it takes, or is it sort of, does it like complicate the interaction between these components more?
I think the proposal is that in the ESNI record you put in DNS, whoever's configuring that knows what the default hostname would be, and just puts it as an entry, right? Puts it into that structure.
So I mean, all the existing stacks that I've seen, the NSS1 and the Pico TLS1, you just give the stack a giant, whatever the heck appeared in DNS is one giant monolithic blob. I think that the difficulty here is going to be that this is going to manifest itself as a connection, depending on exactly how it's implemented, is going to manifest itself as a very funny connection state where it's like, I've connected, but like the cert's all wrong. And so you're going to need some way to basically say, basically have to bypass all cert validation logic and say like, listen, you connected, but like, this is not really a connection. And like, if you make this API call and the other API call, well, you do cert validation, but it gets a different cert because the connection is not live, right? And so it's like, listen, this connection, don't try to write in here this connection for God's sake. But like, but like, if you call this other API call, you'll get the ESNI blob, which you get back to me, then like, I make a new connection, and that'll work good. So I think Lorenzo's right. It would complicate the API substantially. I mean, I'm not saying it's unfixable, but it wouldn't be like totally straightforward. And the fear I would have would be making sure that the stack does not ever put you in a position where this suicide connection that doesn't work properly is writable, and you're sending data down essentially the wrong pipe. Because it's not like that's not a because that really, I mean, that is not a secure relationship, right? I mean, that is like you got, I mean, you have a secure connection to someone whose name you can't actually trust. And so it's absolutely unsafe to ever write any data down that under any conditions.
Yeah, this is just an initial proposal, and it's definitely not perfect. You could potentially imagine restructuring this in terms of not two handshakes, but an extension of the first handshake. But again, that would really complicate what TLS looks like.
So this also assumes that the fallback hostname does not change as well, and so
that's right.
And so, or it changes slower than the SNI key at some point. And also, like you could get into other situations by this fallback connection is used as a the suicide connection, as Ecker called it, is used for the other requests. For example, if the fallback hostname certificate actually does contain a valid hostname of the, or a star dot or something, then what is the policy that the client should use? Should it still terminate the connection, or should it use that for coalescing the domains?
Yeah, good point.
So I think I'm kind of confused as to what this fallback hostname actually is, but that's probably okay because it's like not written down yet. So it's not just to clarify, it's not a kind of name for the fronting server or for the backend. It's just a third name entirely.
It would be a third name entirely. You could imagine someone creates a sort of a random string subdomain and
okay,
puts it into ESNI.
So, but I think more generally, I mean, I think the point you had on the previous slides, I mean, I think there is I think it's probably fair to say that the current proposal, and maybe this, is friendly towards TLS developers. I don't know if it's friendly towards DNS operators. Because I think, like, having the not before and not after in the ESNI keys seems to me to be a bit odd. It seems to create new corner cases when you compare it with other kind of TTLs and RRC kind of validity periods and so on. So I guess I would ask that at some point we try and make sure that what we're proposing to put in DNS is something that people would like to put in DNS more generally than just the people deploying. Yeah, but
if we don't want to move quickly, yeah.
Okay, thanks, Stephen.
Lorenzo Coliti, so my first instinct is this is a configuration error, right? In theory, or is it not a configuration error?
It is a configuration error.
Okay.
It's one in which, because of privacy considerations, there is no fallback.
Yeah, it's very damaging configuration error. How much do we think it would hurt adoption of this proposal if we basically declared it to be a configuration error? I mean, you can create other configuration errors, like hand out the wrong IPv4 address in your DNS, and yeah, the site's also unavailable in that way. So if you have we tried to say, look, we could say this is a configuration error, don't do this because it's really dangerous? And
my sense is that some clients would not deploy with this risk.
Does that matter? Is it like critical to the adoption, or is it like, yeah, some people won't do it and they'll do it later?
I can't speak for the organizations. I don't think they have a representative here, but yeah.
Rich Salzakamai, yeah, we would have a real hard time. We want to deploy some kind of encrypted SNI. We would have a real hard time deploying something that had this kind of failure case, because people who want ESNI really want that privacy guarantee. And if all of a sudden we go, oh, and we're running the DNS server, and it's not just a config error. Networks break apart. There's all sorts of things that can go wrong. That even if your configuration is correct, you can still get inconsistent results on these kinds of things. You really need an atomic fetch, which is why, the proposal of a new record type. It seems that DNS folks are waking up to the fact that parsing text records with the regex doesn't work, and so new record types are amenable. And yeah, any work on this would have to involve the DNS folks, and I know that's the intent.
Ted Hardy, pretending to be a DNS folk for just a moment, that they've actually been recommending using new RR types for quite a while now, so really not their fault. There have been deployment issues that have made other people recommend that you do not do it, but from the what is the one true way? New RR types have been the one true way for a good long time. But I actually wanted to kind of go back to a question that I think both Stephen and in chat, maybe Martin were getting at, which is, can you end up in this situation in essence because of a clock skew problem, where you have something where you think this is fresh data, it's not fresh data, and they're out of sync because the DNS client doesn't know that it ought to be getting, it's time for a new fetch, right? And there's a question in my mind about this and the way that the document is currently, and I assume in the new one, describing how long the records would be valid for. Because if you're actually trying to define that using the DNS primitives for how long the record itself is valid for, then allowing somebody to order the records by validity isn't possible. Right now, you basically say any of these records can be used, they're all valid. If there's multiple ones of these records, they're all valid. You could actually cause the structure of what you include in the record to include validity dates or other timing information that would allow you to tell that the two different ones you got are actually meant to be used sequentially. Oh, sorry, it does have that, and I just missed it. Sorry.
There's a
Window.
Yeah,
Okay,
there's a
so
time window. So you
then
don't
I
have
just
to
missed it
trust
in the
DNS.
draft. My apologies.
Jonathan Lennox. So I misunderstood the suicide connection thing in a way that I think might work better, which is why can't you just restart the TLS handshake from scratch over the same connection after you've gone through this dance, which could then hide all this complexity, which then the TLS stack could hide all this complexity from the application or the transport layer. I mean, obviously it's going to cost you a few round trips, but in this weird configuration error state, I think costing a few round trips rather than a hard failure is definitely a win. Ecker said he didn't think any stack developer would be willing to do that. I mean, just start from scratch, treated as a new handshake would be problematic.
My understanding is that you might already have something in the pipeline for this connection, and doing the connection management is tricky.
Also quick. Quick when you're with the TLS stack is at a goofy position with respect to the.
Okay, we got about 2 minutes and 30 seconds left for this.
Okay, well, good thing I have no proposal for the next problem.
Yeah.
So the next problem is the multi-CDN case. This is how a lot of sites are configured, such that, well, I guess there's two main configurations. There's either on the apex or on a subdomain. On an apex, you can have it configured so that depending on who's requesting or the location or the time, you could have the authoritative DNS provider return a set of A records corresponding to one provider or another provider. And these providers are likely not going to be sharing ESNI keys. And you have the option, there's potentially a situation where one provider does not know about the other provider, or one provider supports ESNI and one does not. So the question is, if you do obtain these two queries, it would be you query A or quad A, and then you also could query for the ESNI record, and they could end up pointing you to different providers. There's nothing atomic connecting these two requests together. So getting out of sync would result in encrypting SNI to the wrong provider's key or to a provider that does not have ESNI enabled. As another case for this, this is, I guess, more common, is if you have a subdomain such as www, you can do load balancing via CNAMEs. So you would send a CNAME to one provider, CNAME to another provider, and these would also be sort of alternating. And based on various load balancing policies. And so in either of these cases, the current draft does not have a solution. It does result in connections failing. And unlike the previous slide, in this situation, there's no way to do a default hostname and recover, because you're explicitly getting a different ESNI record from a completely different provider. So this is an open question, and one that seems like a very difficult design space to work in.
Lorenzo Colletti, this is because the SNI key is actually a property of the destination IP and not of the host name, right?
That's right.
And we have not thought of like putting it in the adder ARPA or something. Okay, who doesn't like it? Nobody. Okay, sounds good to me.
Okay, so I wanted to raise this as an open area for I guess design considerations for this, and from the folks who are interested in implementing this, this is a very big blocker, and it's one that would stop the deployment of ESNI in a lot of situations. Okay, so Requirements for a solution, you want to prefer soft failures to hard failures. These are also open up for debate. No serialization of DNS queries is another potential requirement for this. If you have to do 2 DNS queries in sequence, it's not desirable compared to right now where you can query them both simultaneously. This needs to work in a majority of deployment scenarios. And we prefer fewer changes to authoritative servers in finding a solution here.
This is DKG from the ACLU. I just wanted to point out your top 2 bullets seem to be a little bit in conflict, and I think it'd be better if you rephrase the second one as as I point, the slides are changing.
Yeah,
so it's
this one.
So, yes, this one, thanks. Yeah, in the normal case, no serialization of DNS queries, but the soft failure could well be a serialization of DNS queries in order to resolve it, right? You don't want to rule out serialized DNS queries as a way to deal with the soft failure.
Yes, I guess so. Okay. Yeah. I guess you don't want the serialization in the general case.
Actually, we don't have any time for questions. I'm sorry, we're already way over, unless you can make it very, very brief.
Sure, yeah, it's just a question about the dependency on the backend server. Because I noticed there's a remark in the current draft which says that the backend server can be unmodified, but with the introduction of the nonce, it has to be sent back. Yeah, so that's, so I guess I just want to clarify that the draft needs to be clear on the dependencies on the backend server going forwards.
Yes, that's a bug. Yeah.
Yeah, to be fixed. All right, thank you.
Thanks, Nick. All right, so the next item on the agenda is the proposed charter text. A couple of weeks ago, we sent around an initial proposal. We thought now that we have 1.3 finalized, it'd be good to sort of address what remains with respect to, holes in the TLS ecosystem and to finish up existing work that's already been started. So there are 3 main items listed here. The first of which is to finish up DTLS 1.3 and everything that entails. The second of which is to sort of add mechanisms to sort of improve the usability, deployability, extensibility, et cetera, of TLS and related protocols. And the third of which is to sort of recommend deprecating, removing, getting rid of old bad things as time progresses. So hopefully we can use this time to sort of talk about the text as proposed, to change things, identify issues with what's written, and so on. So Martin,
So I realize the rule of 3s is quite nice, and you've done that very well here. 3 bullet points, 3 actual points. But the first one, given the discussion that we had earlier in this session, might have already happened. And so I suspect that we're going to find that this charter is no good by the time it gets approved and published, if that first item is in there. So maybe we can take the DTLS one out and just concentrate on the other things.
Most likely, yeah. So I was going to propose something different, which was just to sit on this for a couple months, and then, I mean, feel free to write a new charter that doesn't have details in it, but then we can, and then sit on it until we publish details, and then we can recharter. That'd be my proposal. I mean, there's an AD right here, so we can ask him what he thinks, but it's kind of I find recharting kind of a pain, and I'm constantly screwing it up. So, I would hold off on that.
Martin? Yeah, so I guess the point there would be that the current charter covers TLS 1.3, and we can just say, well, TLS 1.3 obviously means DTLS 1.3 and carry on, and then we'll deal with the other stuff when that gets done. It's only months. It's not like it's going to be forever, I don't think.
Yeah, that's perfectly fine as well. I guess we're interested to know if the remaining issues, putting DTLS aside, are of interest to the working group, should be in scope, should not be. We don't have to necessarily do the recharting right now. We can, of course, wait for details 1.3 to be finalized, but sort of identifying what are the next big things we should be working on, I think is a useful exercise. Stephen?
Stephen, yeah, I mean, I think maybe leaving this for a few months might make some sense just to simplify the change. I don't have a proposal for how to do it, but if you guys are clever enough to figure out some text to say what we don't want to do, that would be very useful, because as we've seen again today, that every time you try and do something, there's somebody who wants to do kind of the opposite. So I would encourage you to try and think if there's any way you can kind of say that, here's what we want to do, and here's a characterization of the things we don't want to do.
Yeah, noted.
Hi, Nick Sullivan. Just one word that I'm not seeing in this second working group goal is security. It's part of the security area, but if you're talking about proposals regarding, say, new threat models, PQ, et cetera, could be worth explicitly saying that.
Yeah, that seems fair. Sort of a follow-up question to that, do you think items such as PQ should be considered when we do actually conduct the rechartering exercise?
I think the next presentation is going to be in that vein, right?
Yes. Does anyone have any other comments, criticisms, et cetera, on the existing text? If not, we can move on, and we'll discuss when we want to actually do the rechartering. Like I said, we're perfectly fine to sort of table this for a while DTLS 103 is finalized. There's no rush, but just sort of getting a feeler for what the next big things are to work on was the point here. So. Yeah, perfect. All right, so Russ.
No one has stolen the clicker yet.
Hello. So I've talked about this a couple times. And then we had a call for adoption and it did not succeed. So I want to go through a little bit of history. In Montreal, no one objected to the base case that was in the document, but two cases were discussed that people wanted to include in addition to that base case. One of them was to provide some proof that the server still had access to the private key that was in the certificate, and the second one was on resumption to provide a different certificate, yet avoid the conflict that if there's early data and you're doing resumption, if you were to change certificates at that point, you wouldn't know if the early data belonged with the old certificate or the new certificate, so don't allow that. So I added those two cases into the document, and then there was a complaint that, whoop, now we've gone too far, it's got too much complexity. So the question is, that I'm hoping this presentation will answer is, where does the group want to go from here? So just as a bit of providing you enough context to answer the questions that are coming, this is the handshake where it's for the initial handshake where you're including a pointer to an external PSK to be mixed into the key schedule. This slide has not changed since the last presentation. Then the case where resumption and you're proving that you still have the key that is in the certificate, or the private key that corresponds to the key in the certificate, is this one. And when you are changing it, you can't have early data, and that's what leads to this case. So I have three questions I would like to have the chairs ask the group. And there are these three hums. So I don't know which of the chairs I'm handing it over to at this point. All right.
Right, so we talked about this. You said in Montreal, there was a couple objections that have since been clarified. So Ben or Ecker, I didn't know if you were getting up to talk about it.
He's the ED, I'm going to say something.
Ecker.
Yeah, I mean, I guess I want to take the temperature before we do any of this stuff. I want to take the temperature on how much enthusiasm there's for this document, as opposed to how much not objection there's for this document. Particularly, I'd like to see. I'd like to ask if people actually intend to implement this.
So you want a hum 0 in the front of this?
More or less, yeah.
Okay.
I mean, or people come to the microphone. This is, I'm not sure I don't like this, but it's not on my implementation roadmap, and I want to present it on anybody else's. Because I guess, like, this isn't about this particular, just to be clear, this is about this particular document, but I feel like this working group had a lot of trouble over the years by taking just things that people didn't object to, and so I want to take things only that people are enthusiastic about.
So Stephen Farrell, just a question. So if you got a positive hum for all three of these, are we still meaning, does that mean that people still can later on decide they don't like the document overall and don't want to adopt it? So are you asking that for an answer of the form, if the working group were to do this, I would like 1, 2, and 3, but I actually don't want the working group to do it. I'm not saying that's my position. This is just a clarifying question. I don't understand. Are you asking? Are these hums asking for implicitly asking for working group adoption?
If you had a document that had the outcome of the hums put forward for adoption, I would hope that you would get a consistent answer. But obviously, the group changes over time.
But it's not just over time, because if somebody has an answer for hum 1, that doesn't mean they want to adopt a document with position X for 1 and Y for 2 and Z for 3, right?
That's correct.
Ben Kato, just touching on the, who's going to implement a question, that doesn't have to be a hum. That could be like show of hands.
So let's just do that. Can we have a show of hands of people who would, who have read the document? Okay, it's a pretty good number, say 20 or so. People that are planning to comment on the document if it's going forward. All right, less, but some. Who's planning to implement the document? One.
I saw 2 more.
3 more. So yeah, so there's a couple. That's a stretch in the back there. So it's a couple.
No,
it's not. It's certainly not overwhelming, but it's.
You're not talking to the mic.
Rich Sauls, yeah, but it's open source and we take pull requests. And if this meets somebody's real need, then it could show up. It doesn't have to mean that I'm going to write the code or that Ben, would write the code. So it's not quite a fair question. I mean, I understand, yes, it's good, but I don't think the lack of answers you got are definitive.
Again, what I'm trying to get at is, do people in this working group think this is like a positively good idea? Or is it just like that Russ is like in the front of the room and we like Russ and like this is like and it doesn't seem like terrible and like, we don't even mean, like if people think it's a positive good idea, then you ought to be willing to implement or solicit someone's implementation or hope somebody else will implement or something, right? And that's, so I mean, like I can imagine a bunch of questions, but I guess what I'm asking is for other people to get the microphone who like this and say, we think we should adopt this and we're in favor of it.
Well, for now, I just trust Russ.
Ben Kato, I mean, so I think there's a real need here. It's just not a need that I have. And the people who have this need may not be in the room.
While Nick is disentangling himself. Steve Farrell, so, I mean, I guess there is a real need here, but I have a slight concern that maybe we're being a bit premature in trying to assume we know that this will solve the need. So, it may be that, after NIST have the competition with new algorithms and so on, maybe there's going to be something that people would want to implement much more than this. So I don't know, I'm not against this, but I don't feel confident that this might be the thing that saves the day.
Well, I certainly don't see this as an alternative to what's going on with NIST competition. It's more of a gap filler until those get sorted out and implemented, and then we find out whether TLS-13 supports them or we need to do TLS-14, et cetera.
I like this all implemented I have a specific use case. It's not the same as the typical use case, but I think this is good to have. Signatures on external PSKs especially.
So is there anybody that's in violent objection if we adopted this?
Didn't hear it.
Yeah, a use case would be a specific non-public PKI, service to service.
Not violent, but I'd like to propose that if we drop it, we drop it as experimental, not as proposed standard.
That'd be fine with me.
I mean, I guess if we were voting, I'd probably vote against it, but I'm not going to like stand line from the road.
Martin Thompson, I was wondering whether I even got up for this one, but I'm going to say it anyway. I was originally sort of enthusiastic about the second point.
Yes, you were.
I'm learning to sort of downscale my expectations with what it is that I can ship, and so that one is no longer something that I think we can do in the short term. Not opposed to it, and still think that any solution here has this property, and that would be good. This document came up in discussions related to the PAIC draft that was going on at the moment as well. There was a desire there to use some combination of certificates and the PAIC stuff. So just wanted to blow your mind just a little bit and expand the scope even more. But
that's exactly what I was thinking.
Right. So yeah, definitely. I think the experimental sounds like a reasonable way to start thinking about this one.
This is also not a concrete use case, but what we were talking previously about ES&I, there's a potential to use something like the second node to distribute the S&I in a specific situation. Not sure.
I guess so. I think where I am on this is that I don't think right now people have the energy to properly analyze 2 and 3, and so I think that I would not be in favor of taking 2 and 3. I would like to do 2 and 3 at some point, but I'm like cognizant like how wiped out everybody is from like doing 8446 and presumably whatever the heck we're going to call it, details 1 3. And so I think I would hum like definitely against taking 2 and 3. If people want to take 1 as experimental, I can live with that.
To put it like a finer point on this, right? Like Russ wrote number 1, and I think Martin was like, "Hey, number 2 would be great," and then Nick said, "Hey, I'd like to number 3 too." If Martin and Nick are willing to say, "Yeah, we can wait to do it later and let's let 1 go through as experimental," there's a lot less hums to hum. So
take 1 home.
So
we really want to do 1 first and the other 2, there's not a pressing need for 2 and 3. So to say same as I believe with Martin, but it would just be a shame to build this machinery and not use it for these use cases.
all right, so we're gonna hum for whether this document should include external PSKs with certificates for initial handshake. So hum now if you think this document should be limited to just external PSKs with certificates for initial handshake. Please hum now if you do not. So that's rough. And we're going to have it go as experimental. Okay. I can do that now. Please hum now if you would like to adopt this draft. Please hum now if you would not want to adopt this draft. If there anyone that hummed no, would you like to get to the microphone to say why? Great. Okay. Next, cars. All right. Think. All right. Hopefully these are the updated slides. You're welcome. Yeah.
Hello, I will present you today the transport layer security extension to support IEEE and HC certificate used on vehicular network. So the agenda would be, I will give some motivation and objective of our extension, then an overview and also some use cases, how and why we are using, we need this extension. Finally, I will give some details of how we made it on the draft. So, cooperative intelligent transport system is a high mobile environment with a limited bandwidth. That's why X509 certificate is not optimized for delay-sensitive and limited bandwidth application. That's why on CATS and vehicular environment, we are not using X509, and we switch it for IEEE and HC certificate. IEEE is 1609.2, 1609.2, and the HC1 is 103097. And I have to mention here that the HC1 is just a profile of the IEEE. That's why we intend to create add just one profile on TLS protocol. So the objective is to make authentication, to have this authentication method more optimized and more appropriated to the vehicular environment, and to enable client and server authentication in using CATS certificate. Some use cases, we can use this extension for uploading logs from vehicle to server of log, or to make updates of vehicular software, or to make update of configuration, just the configuration of software embedded on the vehicle. And it can be used also for connected cloud services, connected infotainment, and it can be used for authentication between client and server, for example, of the car rent company, for car manufacturers servers, and wireless electric vehicle charging. So there is very an urgent need in CATS, let's say, world for this extension. So we propose to add a new number for 1609.2 certificate as a new certificate type, and we defined its entry like we present here on the slide. And here I give an example of handshake, where the client is declaring that he can support 1609.2 certificate, and the server can send 16091 X509 or raw public key. So the answer of the server is the X509, the default one, and the client certificate type would be 1609.2. This, which is compliant to the last RFC of TLS 1.3. So just to add one information about privacy consideration made by this kind of certificate. In fact, it's provide privacy relying to temporal and locality and geographical and temporal validity criteria, and minimizing the exchange of private data. If this draft will be accepted, we will ask IANA for a new value to register this certificate as TLS certificate type, new TLS certificate type. Thank you.
Can I see a show of hands of anyone who's read the draft? A couple. All right, that's cool. I got questions.
Hi, this is Hannes. I was sorry, beat you. I was wondering why you can't just register a value. Is there really, did we establish the registry in such a way that it requires an RFC for in this group specifically? So why can't you just do that? Like it sounds like it's great. You use DLS 103 or DTLS 103 in a vehicular environment. You use another certificate. We defined one other things earlier, like the raw public key. Looks like fairly straightforward to me.
You mean introduce the IEEE one on raw public key structure?
No. Apparently,
yeah.
there's some work going on in the IEEE on this. Can't you just in your specification at the end, like send a request to IANA? There would be an expert review, and then with this new value being added to the registry, I don't think there's there's a barrier on defining a new certificate type. At least, like you don't need the IETF document to do that.
In my understanding, I have to make it as a draft, and then I ask if it is accepted. I will ask a value from IANA.
No, you're right. Yeah, because I was working on a raw public key with some other guys here, and I remember that at that time we didn't have to do anything. It was just we added some other extensions. That's why we had to write a draft for it, which later became an RFC. But I think in your case, since you only need this value registered, I don't think you need to do anything in the IETF besides sending a mail to IANA to add that to the registry.
I already sent a mail to Stefan, I think, Stefan Farrell, and he told me that I have to get the acknowledgement.
No.
Yes.
You don't. You just
okay.
You just have to if there's already a public specification available.
Yeah.
That's it. You just then make a request.
Okay.
This is the part I tried to explain to you. It kind of changed under your feet since it started. Now you can send in a draft, a pointer to an internet draft to say, here is the thing, and I would like this value assigned. So, so you don't even need to go through the rest of the process or get us to adopt it. You don't even need a draft. The thing that is interesting in this draft, though, is if we're going to progress, I think that I'd probably take some of the things out. Like there's in the security considerations, there's like a recommendation for a minimal profile. That doesn't really kind of seem to fit in this draft. I think that would be better in an IP wave document or somewhere else to specify that over there. Because this is this TLS extension thing, if you use TLS, use this other stuff, just, it doesn't kind of really seem to fit in that particular, in this draft, because you're just defining this new particular certificate type.
Yes, I can push it on IP wave group, but still TLS extension, so it must be, I think it should be discussed here.
Well, no, I guess
TLS
I agree discussed, but the point I'm saying is the ones that are already defined, and you're saying when you do a connection, you should only be using these extensions. That I don't know that even applies here in the document. It doesn't make any sense to me. It's a profile essentially of how you would do it, and I think that goes someplace else. It doesn't belong in this particular extension document. The other thing is, I think you would put a big old warning in the security considerations to say, hey, look, we define new certificate formats, which also have new processing rules. They are different than what is done in regular X509, and dragons be there. They finally got fuzzed enough to kind of work, right? And we kind of know the pitfalls at this point. These are new. I've never looked at them. I sure hope they work properly. So that would be a new security consideration, I think.
Yeah.
But I mean, I think at the end of the day, if you could clip out some of this stuff here, if you send a request to the TLS Reg email list that I put up there earlier, I think you could get a code point probably by the end of the month.
Yeah, because we started with, I think it's a new process. It's
relative
procedure. Yeah,
it's relatively new. So, okay, thanks.
Thank you.
Yeah, specifically, it's like 2 months old, so it really did change out from under you.
This is Russ Housley. My understanding is as long as you can live with a number that is being assigned that is 64 or greater, you don't need to do anything more other than ask IANA. If you want a
Yes.
small number,
Yeah.
then you got to go through and get a standard Strack RFC.
But in the past, it was not the case. That's why.
That's the way I read the ranges.
Thank you.
Thank you.
You're up. Right. So this is something we talked about right near the end of finalizing TLS 1.3. In particular, there's some oddities around external PSKs and how you use them properly for this new version of the protocol. So there were two basic designs that were discussed on the list. One was from David Ben describing universal PSKs. The other one was this key importer idea that Ecker and I had talked about. So this is just kind of getting that down in writing, and hopefully we can kind of make a decision as to which of the two we are fond of, I guess, assuming we want to address this particular issue going forward. So just some pointer to the text in a 446 that says, if you're going to use a PSK, make sure you only use it. It must only be used with a single hash function in TLS 1.3. And be wary if you're using the same PSK across 1.2 and 1.3, because we haven't really looked at that very closely, and there be dragons possibly. So, like I said, we want to only use a single hash function, or PSK with a single hash function in TLS 1.3, whereas TLS 1.2 has no particular restriction. And we want to make sure that if we are to use PSKs that were provisioned for 1.2 or other versions of the protocol, that it's safe to use in 1.3. Ideally do it in such a way that you don't have to tie details of TLS to the provisioning process of the PSKs. You can kind of just reuse the machinery that's there and then sort of suck them into TLS 1.3 and use them as such. So the analogy that I'm kind of drawing on for the importer is exporters, which, as you may know, you have some secret exporter master secret inside the TLS box. You input some label and context, and now you get as a key that's for the specific context with the derive using the specific label, and it sort of diversifies the PS, whatever the early master secret is using that particular information. Importers, in contrast, are sort of a way to take an external PSK and diversify it by the supported hash functions that a particular TLS 1.3 implementation happens to have. So assume you have a PSK that's provisioned out of band. It has some external identity, and you have some label you want to associate with during the import step, and the label here is bound to a particular like a protocol in which you would import the PSK. So if you're using TLS 1.3 over TCP, the label might be TLS 1.3. If you're using TLS 1.3 in the context of Quick, it might be Quick, so on. And you have a particular, like I said, you have a particular hash algorithm that you want to use this particular PSK with. The basic idea of the importer is you form the identity of that PSK as the tuple effectively of all these fields, and you use that to derive a per hash function, per hash algorithm PSK that you would then use to compute binder values and send to the server and the client hello. So depending on how many hash algorithms you support in your particular stack, you may have one or more actual PSK binder values that are sent in the client hello to the server. Seems pretty straightforward. Illustrated as such. So you have some external PSK associated with a hash algorithm. You HKDF it with the identity, with the label, and the hash algorithm that you are using to split it up. So if you support all versions of SHA-2, you would have 3 binder values that are sent out the door for this particular PSK. And if it's important to note that the hash algorithm used for the HKDF operation here is that which is provisioned with the PSK, not the one that you're using to diversify the PSK during the derivation step. So it's not like SHA-256, 384, or 512. It most likely would just be SHA-256. And if it's not specified in your provisioning process, just use SHA-256 and be done with it. Some constraints for this particular importer design are that if you're going to use it for early data, that the spec clearly kind of indicates that you need to know information about the context in which you're going to use it. So values for ALPN and other quick transport parameters. The draft right now is sort of just kind of hand wavy in that particular respect. So, we could certainly do something to improve it. There is the issue that was raised on the list with respect to privacy and privacy with respect to the labels that are being used, but perhaps that was my own fault in not being clear on what the actual labels are. So they were merely intended to diversify importing PSKs for different protocols, be it Quick or TLS-1.3 or whatever you're going to use TLS-1.3 for, not as identities associated with external PSKs. The privacy issue with external PSKs is still very much an issue that potentially is orthogonal to this whole problem. And there's not really much specific details around how these are sort of compatible with TLS 1.2. The TLDR is that you don't really do anything specific for TLS 1.2. There's been proposals that have been discussed to potentially essentially import for TLS 1.2 using the label TLS 1.2 and use that as your PSK value. Probably fine, but wasn't something I was trying to do for the initial version of the draft. Yeah, on this.
Chris, if you go back to the previous slide, so you have this key derivation function for the PSK. What about the PSK identity? You keep that unchanged?
No, it is this particular structure. So it's this entire value that's sent.
Okay.
Yeah. So the server, upon receiving, an external identity and a hash algorithm, they'll know which PSK to derive and they can verify the binder with.
Yeah, because otherwise you would suddenly have you have a client that doesn't have that extension that you're proposing, and then a server that has it, but the same key identity is used. That gets totally confusing.
Yes, that would be bad.
Would that go into the TLS stack or DTLS stack, or would that stay at the application layer?
When you say that, what do you mean?
The implementation of your document, of this.
Inside the TLS stack.
Okay.
Yes. Well, I mean, clarify, but my understanding was that, or the implementation that we put together was inside the stack. You would, in importing PSK, you'd just be given an external identity and a PSK associated with it, and then the stack internally would do the transformation and derive all the PSKs afterward.
Oh, well, I mean, you could do that. That was not mine. This design is specifically intended not to require that.
So you can do it, I guess, you can do it either way, but it's nice to just sort of have it imported. The interface be simply have an identity associated with it and a PSK value, and the transformation happens internally. That seems most intuitive to me.
That's a reasonable aesthetic position, but it is not mine.
Okay, but that seems to be an implementation detail, right?
Well, yeah, agreed. The important point is that is not required because this is consistent with the existing API. If all you have is a standard PSK API, you can use it this way by by pre-generating all the PSKs and shoving them in individually this way.
Yeah.
I'm just worried about sort of exactly this compatibility between a client implementing something, the server implementing, or some party not implementing that extension and the other one does. And so you get this weird error cases with PSKs, like we already had previously with PSKs when people use different encoding at the user interface, and then they're just failures, and you have to go through the log of the TLS handshake to figure out what the failure case is, because the error messages in TLS for PSK are not very enlightening.
Yeah, something certainly to consider. I mean, you might possibly consider some other signal to indicate that this client is using this particular extension, and maybe the server can operate on that, and maybe that will help your debugging issue. What? Yeah, so there's a lot of things missing from the document.
Ben Kato, so I mean, we're saying extension, but this isn't like a protocol level extension. This is just
no, it does not change the protocol in any particular way.
Right. So I mean, it's just a fact. You've got so if it's like a mismatch between one side implements and the other side doesn't implement, it's just you're getting a PSK identity offered that you don't recognize.
Yeah,
and yes, the normal behavior in this case is not super great, but it's not catastrophic either.
Yeah, so Martin Thompson, I assume that in the case where you plug one of these in, you're plugging this entire struct in as the identity, not just the first piece of it. So it's possible for someone when there's a confusion between the two endpoints, the identifiers that are used for the keys are different because this has got extra in it.
So my implementation and my understanding was I would just plug in the first thing. and then construct the rest of it internally. But
oh, okay.
So I guess, so let's take a step back. A conventional TLS-13 stack, the one you have today, if you had PSKs, what it would do is it would take a external PSK, and it would be attached to it would be the key to use the hash function to use the TLS handshake and a label. Those are the triple things you get, right? And so there are two implementation options for doing this. Implementation option one is to externally generate a new set of PSKs from that initial triple that have each of which itself is a triple with the new attached hash function, and just shove them in the interface exactly as they currently were. And they have names that are synthesized in the way Chris indicated. Option two is to have a new interface on the outside that says, here is a PSK that you should never use directly for TLS, but is a root PSK that you can use to derive other PSKs according to this function. And that's what Chris has done.
Yes.
But those two implementations ought to interoperate just fine.
Yes. So the interface that I have in mind is specifically an import this PSK, import this external PSK, not set external PSK, given this blob. Yeah. But again, purely implementation detail, and hopefully they do interoperate at the end of the day. Yeah. Right. So the other design that I mentioned earlier is that from David Benjamin, just sort of similar in some respects. The basic idea is that it sort of abstracts the general idea that you only want to use a PSK with one particular hash function in TLS 1.3. The design basically takes the external PSK, uses it to derive a new PSK to compute the binder values in the client hello. And if the server does indeed verify the binder and negotiate a cipher suite, you then afterwards derive a per cipher suite or a new PSK for use in the key schedule based on the negotiated cipher suite or the hash algorithm associated with the cipher suite. So in effect, you're sort of changing what PSK value is injected into the key schedule. But the benefit is that you're only sending exactly one PSK over the wire, which is the sort of fundamental comparison difference between the two. So with the importer proposal, you have an inflation in the number of PSKs that you're actually, the binders that you're actually sent over the wire. You're not changing the protocol in any particular way. With universal PSKs, you are changing some of the key schedule details. But again, you're not inflating the client hello unnecessarily. So which one we prefer is I don't really care. I think we should do something here because many people use external PSKs. I would like to use them for TLS 1.3 in a safe way. I just need a way to do it. So then.
All right, Banketa. So, I mean, we should be clear about what we're actually doing. If you're sending multiple PSKs over the wire, you're sending the PSK, which is, or what? So you're saying the label, and then you're also sending the binder.
Yep.
And the binder is the full width of the hash output.
Yep.
And so, if you're talking, that's minimum 33 bytes, because you got the length field for each binder you're sending, and more for the larger hashes. And so, if we're only going to be sending SHA-256 and SHA-384, which are, the only two hashes currently with TLS 1.3 cipher suites associated to them, maybe that's not so bad. But if we start getting into, we're sending 6 things on the wire, that's kind of large and might start to impact our decisions.
Yeah, absolutely. Something to consider.
Yeah, I mean, it's true. I'm not overly worried about that, to be honest. We've gotten pretty far without very many hash functions. I think that for me, like basically, I felt like universal PSKs did like way too much violence to TLS for something which I didn't think was like actually as valuable as perhaps other people did. So, I mean, the design of the importer specifically designed not to do that violence to TLS. So I guess, I'm sort of like lukewarm on the whole thing, but like I'm negative on universal PSKs, I think, at the end of the day.
That's honest. So we use the PSKs for some of the low-end IoT devices that don't have enough sort of RAM, flash, etc. For the public key crypto. So I understand that it's not particularly useful in the web context for a variety of reasons. But they are specifically for those PSK cases, sort of often the over the wire transmission size also matters. So maybe that's something to take it into account. And I can actually point you to some of the products we have in that case, because it's not only used by us, but also by others.
Yeah, absolutely. I'm not saying that that's not an important thing to consider. We should do one of them, and there are trade-offs, yes.
Yeah, I mean, and there's also the question of, if you do have this sort of tightly constrained environment, are you actually going to be sending multiple things, or would you just be picking one?
Yeah, Shawan, I mean.
Jonathan Holland. When you say in a seemingly safe way, do we have any sort of reason to believe that other than, yeah, it feels okay?
It feels okay.
So as a formal analyst, I'd say that sounds terrible.
Yeah, so of course, it does require some analysis. I think David, in his draft, he specifically says, yeah, this is not undergoing significant analysis. And certainly that
is someone doing that?
Sorry?
Is someone planning to do that, doing it?
I believe you just volunteered yourself. No, not that I'm aware of. Are you interested in doing that? That, like I said, that is the one nice thing about the importer. So you don't really need to do any of this analysis over again. So probably someone here is hiring. I don't know.
So is that it, Chris?
No, sorry. There are some more. One more little plug, sort of orthogonal, especially with respect to the issue of privacy that was raised on the list. Kind of wanted to discuss this very briefly. There is this sort of issue with tickets and resumption PSKs in that you may use them, servers may use them to sort of track clients across resumption attempts. Depending on your perspective, that may or may not be a good thing. Say, for example, if you were using, or implementing and using DNS over TLS with resumption to speed things up, the resolver to which you're connecting could link the queries that you're sending over time. Arguably worse in privacy, depending on what day of the week it is. So there are, I guess, a number of different things we could do to address this particular issue. The first of which is if you're implementing TLS 1.3 and you're not actually sending any early data, don't ever resume. Don't give the server any state that is not really useful for anything. Because most implementations I'm aware of, I actually don't know what NSS does, but Boring SSL, for example, will never do just PSK only resumption. It will do PSK with a full handshake. Is that the same for NSS as well? Yeah. Yes. Yeah. Yeah.
I'm not aware of anyone who's doing just pure PSK when it comes to the sort of context we're operating in.
Right. So in our implementation in our system, Apple's implementation system, this is not a big performance hit at all. So that's what we're doing. Other option is if you want to resume and send some early data, potentially use the semi-static approach, which has not yet seen significant security analysis, John, to encrypt the early data with a public key that is shared amongst many people. Instead of a PSK associated with the ticket that's shared specifically between one client and one server. That has some nice properties. We also had this crazy idea to at one point use the VORP, whatever you want to call it. I think that's how Ecker pronounced it, VORP. To instead of simply recover the encryption of a PSK, but to use them to derive PSKs in an anonymous way. And you potentially use that to resume and send early data as well. Yeah, Ecker.
Yeah, so, right. So I think that this is not a crisis. I think if we do anything, we should probably do two at some point. I am having trouble wrapping around how number 3 works. Perhaps.
There is a draft written, not submitted, because it is, I forgot the word crazy in there. It's,
Right. Well, I'm not saying it's good or bad. I'm just trying to think about how it works.
We can talk about it.
Okay. Yeah.
So just real quick, are you saying that number 1 you would not do, or?
Oh, I think 1 is fine. I don't know. I don't think we're going to do it, but I guess that just in the setting of just because of the way the system is kind of constructed, there's 87,000 state vectors, and so trying to remove this particular one while not fixing all the other ones is not particularly helpful. And so I'm basically Like, no, I know what you're going to say.
I'm
but no.
hoping DKG was.
I know, I see it. No, but what I'm going to say is like that the right thing to do is like when you decide to create a cut point, like you flush all your state, and that includes this, and so you just don't resume at all. And like saying like, oh, I'm going to like send my HTTP cookies, but I'm not going to like send my TLS like session ID is like doesn't help. So it's like much more sensible to try to create a complete cut point than try to wear it each individual thing like one at a time.
Yeah, but identifying that cut point is extremely difficult and tricky, I would say. I mean, you can, for example, bound the TLS session state to the lifetime cookies, if that's the relevant example.
That's effectively what you should be doing, yeah.
Yeah, but there are other identifiers, other places in the stack that may not rotate, may not change. Yeah. Yeah, Martin.
You wrote the draft saying that you have to do them all at the same time. Martin Thompson, how do we know that the semi-static DH secret is only sent? It is not only sent to me.
And it's not like some key tagging attack.
You've got a key identifier in there for it, obviously, and that key identifier is state that the client is now mirroring back to the server. So. I think proposition number one is really the only feasible one. It's the sort of thing that we're working to implement, and I don't know that this is used as a motivation to do the second one, although we may want the second one for other reasons.
Yeah, so I second one in particular, still very much a work in progress. We're still trying to actually show that using semi-static for the regular TLS handshake is safe, and we're actually making some progress there with Tyler and some people in Mozilla. But yeah, doing it for early data is still something that we have not really looked at, and we just have a really good feeling in our hearts that it will be safe. That's what matters. Christian.
Christian Wittmer. Chris, I'm a bit disappointed because you present here a lot of mitigations for the resumption issues. My personal risk that I see is that if you have a PSK, you need a PSK identifier. That PSK identifier uniquely identifies the key that you're going to use, and as such is a tracking device. So if you reuse a PSK identifier multiple times, you get tracked.
Yeah, so this is, like I was saying when I transitioned to the slide, this is sort of orthogonal. I just have this slide here in particular to talk about privacy issues with resumption, not privacy issues with resumption with external PSKs and the identifiers and labels associated with them. So this is for the normal, forget that this is actually a slide in the external PSK presentation. This is just sort of.
Are you going to address that?
Yeah, this.
Are you going to address that later?
Address what? The privacy issue. So I don't really.
Issue with the PSK identifier.
I don't really know of anyone who has a good approach to addressing that. Like PSKs, external PSKs in particular, just have an identifier with them.
At the minimum, you need to have a big red warning somewhere in the security section.
Okay.
So yeah.
Okay.
Yeah, sorry. So I should have made it more clear. This is sort of orthogonal to the external PSK issue. It's something that came up during discussion on the list. I wanted to talk about it. Nick.
Hi. To Martin, just to address your comment about the DH secret, not knowing whether this is rotated, I believe you're pointing here. The whole point of this is at a network adversary in which both the client and the server are trusted. So you would trust the client and server to, not to try to trick the client into losing its anonymity. What here you're looking for. If you cross out servers and you say network providers, I think then this makes a lot more sense, this slide.
Possibly, yeah.
Well, but so is this about external PSKs or about resumption PSKs then? Because about resumption PSKs, you're supposed to only use them once because you're supposed to get a new one for each connection.
Resumption PSK. This is about the resumption case.
Okay,
and everything. Yeah.
Right, but then the issue is not network service providers; it's endpoints.
The servers, yes. That's why.
Okay, just like.
Subodh Angar. I'm wondering why this occurred to me. Why we need to have can we still keep the API as set PSK if, for example, you say that the implementation, if you set PSK, what it could do, for example, a strong man could be, it could generate a hash of that element with the intended hash function it's supposed to be used for, and then what it could do is stick that in between the PSK, in front of the PSK identity or at the end of the PSK identity.
I mean, that's effectively what this is.
Yeah, But this it's not exactly that because you're like, oh, we can discuss this afterwards.
Okay.
Yeah.
Yeah. Sorry. Right. So that's the end of it. Sorry for the quick detour with the resumption PSKs.
But can we get a sense of the room if we had to go down the two approaches, whether there's two options, right? Basically one, if I can, is bigger client handshakes. The other one is mucking with the key schedule. Do people have a preference if we were to support this, whether they would prefer accepting the bigger handshakes or mucking? And we could have both, but we're probably not going to try for that.
It's bigger handshakes in the case that you have some uncertainty about the hash function that's used. If you've only got one hash function, there's no difference in terms of size.
Yeah, and in the external PSK, in our particular use case, we know which hash algorithm is supported by both ends, so we would only send one. But I don't know, Hannes, if that's the same in your use case that you had described. Okay.
Are you going to take it home, or do you want people at the mic?
That's where I was going. I was going to be like, bullet number one if there is hum now if you think that this is the way to go, and for the second hum it will be hum now for the second one. Think it's hummable?
Tell me, like in bytes or bits, what bit size difference are. Then I know what how much impact that is. Because for web people, it probably doesn't matter because they are sending lots of other stuff anyway.
I mean, it depends on the label that you're actually providing and associating with the external PSK and the size of the binder value, effectively.
So we will have to look at the details, essentially.
Yes. It's like 50 or 60 bytes is probably the most likely case that is going to actually happen.
I'm going then to the next working group meeting later this week, and there I will be told that TLS and DTLS 103 is awful. We can't use that because it's so heavy, and we shave off 1 byte, and that's why we need to crank out a completely new standardization effort, and then it will be promoted in all sorts of other organizations just because of that argument. Makes me implement 2 different protocols that essentially do the same thing. You know what I'm getting to?
Yeah, I mean, if you care about the size, just pick 1 hash and only use that 1 hash. Then there's no expansion.
Yeah. So Martin Thompson, the point that people are making here is that in a lot of these cases, you've got constrained implementations. They only implement 1 cipher suite. You're only ever going to have 1 hash. So you're never going to have to run into this problem with the binders. Now, it might be that you want to define something, a new cipher suite that has a shorter binder so that you can save even more bytes, but that would require some more analysis and all that business. But right. You have to make some changes and whatnot, but fine. But the point here is that from that perspective, under those conditions, these are not different.
Yes, correct.
And the first option is far less violent to other parts of the protocol. Yes.
So since you looked at this, Chris, for 1 hash algorithm, what is the byte difference between the 2 options?
50 to 60. No, I don't know the exact number.
3 bytes. Oh, that's okay.
So I've been convinced this is not hummable. We will try to take this on the list to see if we can figure out a way forward. Next. Don't go anywhere. Let's do that one.
I don't think it's up.
That one. That one. That one.
No.
No. Okay, let's see if I can break it. I know.
Yeah, I'll do this one.
Where is it?
Refresh.
TLS, there we go, to get robust. Blink.
Right. Okay. So this is something we also talked about in Montreal. The basic idea is that currently most server implementations will just send you a fixed number of tickets, regardless of how many you actually need. So if you're a client who's not only using one ticket, some of these go to waste. If you're a client who needs more tickets and you don't want to reuse tickets, this is potentially not enough. Say the multiple, or you might want to use multiple tickets if you're racing TLS connections in a happy eyeballs v2 kind of style, all the way up to TLS over different interfaces, over different address families. So in general, there's some sort of mismatch between how many clients or how many tickets clients need and how many tickets are vended by servers. So the initial design we came up with was basically a way for clients to request tickets on demand post handshake. There are several issues with this. In particular, I think as a whole, we're not really fond of post handshake things, post handshake messages. In particular, this would have been the first one or the first draft which introduced a client originated or client initiated post handshake message, which is sort of, oh, okay, yeah, right, sorry. It is sort of a non-trivial protocol change, just adding this request response. So that's potentially undesirable. And then there's a story, it's not clear how you actually buffer these reads and writes of the post handshake messages on the client side, potentially, especially if you have them arrive out of order from the server. So the feedback we got from the room is that potentially this is useful. It might be simpler if you just have the client tell the server up front how many tickets it actually needs, and then the server can use that as a hint to determine how many to vend back. So if you are a server who only sends 2 tickets and the client says he only needs 1, then the server could potentially just send 1 ticket instead. Whereas if the client says I need 255 tickets because I'm going to be doing a lot of resumption and the server only supports 2, the server can still send back only 2. It's simply just a hint now that's sent in the client hello and a new extension that says, please give me this number of tickets. I expect to use these in future connections. In the case, for the Apple case in which you're using or racing TLS connections across different address families, across different network interfaces, we would request, for example, 4, and hopefully we would get those. So we could not use the same ticket across each of these particular interfaces and address families if we're resuming connection later on. Orthogonal to this whole issue is that of post-handshake buffering. So thank you, Martin, for sort of bringing this quick issue to the list, or at least sharing a pointer to it. So a client can, by design, request up to 255 tickets. And if a willing server is going to happily provide 255 new session tickets after the handshake is complete, and we're not really doing flow control for post-handshake messages in Quick, that sort of complicates things. There's also the issue of these messages potentially arriving out of order. So this client would have to buffer all these massive new session ticket messages, which may not be great. Also, that there's no way currently to restrict the handshake message size that is sent from a client or a server in the protocol. Maybe that's something we just do in a separate draft. I don't know, an extension to negotiate that. Seems sort of orthogonal to this particular proposal here, but certainly an issue to consider. Yeah, Martin.
Not so much orthogonal if you put a D in front of the T in TLS. So in DTLS, you might receive the 255 handshake messages and start getting only part of the tail of them.
Okay, fair.
And you have to deal with. I mean, you can still, in this case at least, process them out of order. And so as soon as you get a whole session ticket, you can take that one out and return the space back. But you still have that problem.
Yeah, good point. Thank you.
Oh, sorry, I should point out, not a lot of implementations would do that naturally.
Yes.
Most of them will go, well, this one's out of order. I'm going to wait for all the other ones to arrive.
Yeah.
Right.
Subodhangar, I would like to point out that there's a slight distinction between the number of session tickets that you're sending and the size of each individual session ticket, so that the handshake message size limit that we discussed would apply to the size of an individual session ticket versus the number.
Yes.
I mean, so these general issues came up both in Quick and TLS. It's effectively possible, given like any kind of fragmentation or reassembly protocol, to force the other side to attempt to buffer an arbitrary amount of crap. I mean, the only way I'm aware of this, really dealing with this, is restricting the maximum amount of outstanding data, i.e. flow control. I mean, it's not like handshake message size is the issue so much. I mean, it's partly handshake message size, but as Martin says, you can have out of order messages. So I mean, ultimately, it's if you actually want to do something about this, you have to basically say I won't let you have more than so many bytes outstanding. I guess I'm perhaps less enthusiastic about this than other people seem to be.
By this, you mean?
But by this problem, I'm certainly aware of why you want flow control for when you have a bunch of concurrent HTTP connections, but as a practical matter, I strongly suspect you can set really quite narrow limits on what you allow people to do, and if they violate them, just hang up the phone. I don't think you need to get. I think there's a practical amount of the amount of outstanding data should be relatively modest, and so if you set any reasonable limit, you should be able to just deal with it.
Yeah.
So I think as opposed to H2, where it really wasn't important to have flow control, I think if you were to be I don't allow more than 32 kilobytes of outstanding data, you'd actually be in a pretty fine situation. And just if you send more than that, I'm just going to hang you up.
Yeah, it also seems strange for clients to request 255 tickets in the first place. So, and kind of book on yourself there.
Yeah, so I don't know whether we should be discussing that particular issue at the moment. There's a long tirade I have about this in the quick mailing list about post-handshake flow control. And that's a whole discussion which will be painful to have. So probably we should keep those two, if we want to make progress in this, we should keep those two separate. Yeah.
Sounds good to me. Yeah, Ben.
Yeah, I'm just sort of with Ecker, you don't necessarily need a protocol limit. You can just have an implementation limit.
That's fine. Okay. So the response seemed generally positive at the last meeting, so I would like to see if potentially this is something the working group is considering or would like to adopt and work on. Kind of turn to the.
Can we see a show of hands who have read the document? Yeah, that's actually not bad. Can we get a hum for those of you who would support adopting it as a working group item? Okay. Those who would be opposed to it as a working group item? If anybody voted no, feel free to get to the microphone. All right, good. Hey, so one other thing, there's some TLS stuff that's happening at the IETF open meeting. There's some stuff about mission accomplished, HTTPS secure after DigiNotar, and somebody's going to be updating with some recent TLS 1.3 measurements in case you're interested. Thank you.
Anybody need blue sheets?
Yeah, so I'll put it on the right document name so you can submit a new one to ticket pinning thing. Ticket pinning.
So we're going to be talking about.
Oh, okay. Yeah. I mean, yeah.
What is message called?
Do I need a blue sheet?
What session? Okay. Oh. Quickly, there will also be a talk in MapRG tomorrow about OCSB must stapling responses from Nick Sullivan. So if you're interested, attend.